with questions related to them. So it is a graphical aspect of chemistry. So it is on solubility. As you have been discussing before now, you have been talking about water. The portion of chemistry I've been taking is on water. So today we want to emphasize more on solubility curve, which is one of the aspects we need to understand underwater. So how to read solubility curve and how to give answers to questions as regard to solubility curve. So I want you all to pay attention, and I hope that you are going to get what we'll discuss, inshallah. So if you have any question or anything to raise, just raise your hand so I can get it. If you have any challenge, and then we address them together. So as you can see, I want to believe you can see the screen properly. So let me try to enlarge it. Okay. So here we have solubility curve. What is solubility curve all about here? Well, solubility curve, according to what I have here, I'm going to be very specific based on what I have on the slide, so I don't want to beat about the bush. Solubility curves are made by determining the mass of solids that will dissolve in 100 grams of water at several temperatures. So if we want to identify how soluble a particular salt is, what you do is you dissolve that very salt in water, but the mass of water has to be specific. It has to be under a specific mass of solvent, which is water, of 100 grams. And the temperature has to be, noted. So because the mass of a substance which will dissolve in a particular temperature might vary in the way it's going to dissolve in another temperature. So the mannerism used in representing data, solubility of data, in a graphical method is what we call the solubility curve. So the data is then plotted on the graph, and then you can use the graph of several salts and detect how soluble they are going to be in a particular solution, or most importantly, water. And at what temperature are you going to get certain information about their solubility, or if they are saturated, they are unsaturated, or they are supersaturated, which you will see in due course. So each substance has a different line on the same graph. So for example, this is an example of a solubility curve. So this shows the solubility of salt and sugar. As you can see here, on the y-axis, we have grams of solid dissolved in 100 ml of water, and then on the x-axis, we have temperature. So while you are plotting the graph of a solubility curve, you must put at the back of your mind that the y-axis is going to be for the mass of water, that is going to be the mass of, the mass of solids, in which a particular mass, which is 100 grams of water, is dissolved in. Why at the x-axis, you are going to have the temperature. So because sometimes questions always come out in that aspect. So what's the parameter at the y-axis and what's the parameter at the x-axis, especially in JAM? So you are supposed to be familiar and be acquainted with this principle. So let me move further so we can get. Now, here we have a solubility curve. This aspect is to tell us more about how to read the introductory aspect of reading a solubility curve. So we use solubility curve and the plots of new data to determine if the solution is either saturated, unsaturated, or supersaturated. What do you mean by that? If you look at what we have here, let me enlarge this also. We can see that at the x-axis, you have the temperature, and at the y-axis, you have the solubility. And then within it, you have the broken line, which is the curve. That broken curve, which is the curve line moving upward, the line itself, whenever we have a temperature, or whenever you have a possibility of a point on that line itself, it means that the solution is said to be saturated. So whenever you have a point on the line, the solution is saturated. When the point is above the line, as you can see where we have the light color, the light blue color. So the this any measurement above that curve tells us that the solution is supersaturated, and anyone below it tells us that the solution is undersaturated. So this gives us certain information about how to determine if a particular solution is saturated, unsaturated, or supersaturated. So that's exactly the explanation made here. It is said that saturated equals to the plot will be on the line. So that means for a saturated solution, the plot of the given parameters from the x and the y axis is going to fall exactly on the line. So when it's exactly on the curve, it is said to be saturated. But unsaturated solution is going to be equals to the plot will be below the line. So, and then when it is supersaturated, the plot will be above the line, just as the way I've explained on the description below. So you can see here that above the curve, we have supersaturated, on the curve, we have saturated, and below the curve, we have undersaturated. So that is one other point. Yes. Again here, we have we also use it to determine the mass of substance that can be dissolved in 100 grams of water at a given temperature. So what we mean is that if you are given, a solubility curve, from the solubility curve, one of the information you can obtain from it is you have that tendency, or you can have the capability of reading it to detect what is going to be the mass that is going to dissolve in a particular solution at a given temperature. For example, when we look at this plot, when you look at this plot, we get to realize that at a temperature of about 30 degrees Celsius, when you check the x-axis, between 20 and 40, you have 30. So at a temperature of 30 degrees Celsius, when you move up, above, until you get to the curve, right? And then you trace the line, you can see the blue line pointing to the y-axis, where we have about maybe 220 or 230 thereabouts. But we are 220 grams according to what we have here on the graph. So this tells us that at 30 degrees Celsius, the mass of sugar that is going to, the mass of sugar and the mass of salt that's going to saturate the given solution is just 220 grams at 30 degrees Celsius. So we can use this logic to, get information about saturated solution from a given solubility curve. So before I proceed, if you look at the graph very well, and you are asked what is going to be the temperature, what is going to be the mass of the solid that's going to saturate the mass of sugar that's going to get saturated at 80 degrees Celsius. So what you do is you move to 80 degrees Celsius down, then you trace that 80 degrees Celsius up to the point of the curve, right? So where it gets to the curve, then move straight down to the y-axis, and you are going to have something like 360 or 370 grams. So this tells us that the mass of sugar that's going to be soluble at 80 degrees Celsius, that's going to be saturated at 80 degrees Celsius, is going to be about 360 to 370 grams. Okay, so that's that for that. Okay. Now we move to this. I'm not going to talk about solubility for gases. I will be specific about solubility of solid substances. So because that's what is most explicit in our syllabus. So here we have how to use a solubility curve. Use the solubility curve on the worksheet to answer the following questions. So here you have the solubility curve. So let me enlarge it. So we'll be using this curve to answer some questions. So I'm going to ask you questions based on the explanation I have made after doing this explanation at the end of this whole explanation. So taking a look at this graph first, let me do a quick analysis before I proceed. So we have different salts with different, solubility curves. So all the solubility curve have been plotted in a single graph. As you can see, we have potassium iodide at the topmost end of the graph. Then you have sodium nitrate, that is NaNO3. You have NH3 ammonia. You have potassium nitrate, KNO3, and so on and so forth. All these are showing us the description of the graphs, or the description of the solubility curve of each of the salts. Now, for each one of them, there are a lot of information you can get from them. If they are going to be saturated, at what temperature are they going to be saturated, and what is going to be the mass of substance or the mass of solid that is going to get them saturated at that temperature. So let's run down through the question here. So you'll be going forth and back on this end. Now, we have this, for example. I want us to pay attention to this because this is where the work actually begins in terms of technicalities. So we have how to use a solubility curve first. We want to use this to answer the question. We want to use the following questions to have a better understanding of how to get answers from the graph. So if you look at this, we have at 20 degrees Celsius, how many grams of potassium nitrate can be dissolved in 100 grams of water? So that's the question. So at 20 degrees Celsius, what is going to be the mass of potassium nitrate that will dissolve in 100 grams of water? So that is the solubility. So how much soluble is going to be at that temperature? So the temperature given is 20 degrees Celsius. So we go to the graph, as you can see here, we have 20.
Please, please, can you wait? We are still writing the question.
Okay. I'm going to send the slide to you. It's important that you understand. Do you understand? So you have more time to study it on your own. So I just want you to get the principle. So let me go back to the question so you can see what I'm actually talking about. I want you to pay attention. I'm going to send the slides to the DOS. So the unit DOS. So it's going to send it forth to your group so that you can have access to it. So it's important that you pay attention so you can get it. Can I proceed? Can I proceed now? Okay. Now, what is going to be the mass of potassium nitrate that will dissolve in 100 grams of water at 20 degrees Celsius? So we come to the graph. We locate 20 degrees Celsius, right? So you can see the red line where we have 20 degrees Celsius. Don't forget the curve, the solute you are considering is potassium nitrate, which is KNO3. And you can see the way the curve goes, right? So then you move 20 degrees Celsius until you get to the point of the curve. So when it gets to the point of the curve, then you intersect it and you move to the y-axis. So wherever it meets with the y-axis is going to be the mass of potassium nitrate that is going to saturate or dissolve in 100 grams of water at 20 degrees Celsius. I hope that's understood. I want to get your response here so that I will know if I should proceed or not.
Yes.
Okay. Now, let's take a look at the second question. Here in the second question, it is said that at 60 degrees Celsius, how many grams of potassium nitrate can dissolve in 200 grams of water? Right? So note that the parameters of question given here, according to what we have in the graph, is gram of solute per 100 gram of water. So the mass of water given in the question is 100 grams of water. Right? And the question says that we should get the mass of potassium nitrate that can dissolve in 200 grams of water. So there's need for us to understand how to operate with this kind of question, because in the question, in the graph, you're given 100 grams of water, while in the question, we are told that this potassium nitrate was dissolved in 200 grams of water. So what you do here is, since the temperature is 60 degrees centigrade, so you move to the graph. Let's locate 60 degrees centigrade. You can see 60 down. So the salt in question is potassium nitrate, that's KNO3. You can see the curve, the way it goes. So you point from 60, then you move upward until you get to KNO3 where the curve ends, where the curve meets with 60. So, and then you move to the y-axis, and that's going to be 90. So this tells us that 90 grams of potassium nitrate is going to saturate or is going to be soluble, completely soluble in 60 degrees Celsius of water, right? But the question says for 200 grams of water. So this 90 grams of potassium nitrate is going to be soluble in 100 grams of water, because that is what is specified in the y-axis of the curve. You can see it there.
Can you come
Grams
again?
of
I don't
solute.
really understand.
Okay, no problem. Let me take it again. So if you look at the question, it said at 60 degrees Celsius, how many grams of potassium nitrate can be dissolved in 200 grams of water? So you can see that in the question, just like the one we did at first, what do? You go to 60 degrees Celsius. Now, you locate the curve. Don't forget that you are actually talking about potassium nitrate, KNO3. So, and the curve is going upward. So from 60, you link 60 up until it gets to the curve of KNO3, because that's the sort in question. So when it gets to the curve, then you point to the y-axis. You get that? That's where you have the blue indication, right? So that is 90 grams of water. Now the 90 grams of water there is an indication that only 90 grams, 90 grams of KNO3 is an indication that 90 grams of the salt can only dissolve in 100 grams of water at 60 degrees Celsius. Because if you look at the y-axis, they said grams of solute per 100 grams of water. So that means it was specifically said that according to this graph, the mass of water used is 100 grams. So that tells us that 90 grams of potassium nitrate, right, is going to dissolve in 100 grams of water at 60 degrees Celsius. Is that clear? Is that clear?
Yes.
So fine. But if you look at the question says the mass of potassium nitrate that can be dissolved in 200 grams of water. So if 90 grams of water will dissolve, if 90 grams of the salt will dissolve in 100 grams of water at 60 degrees Celsius, it means 90 times 2, that's 180 grams of the salt, KNO3, is going to dissolve in 200 grams of water. Does that make any sense?
Yeah.
No, so that's exactly what was done here. So if 90 grams of water gives us 100 is dissolved in 100 gram of water. If 90 grams of KNO3 is dissolved in 100 grams of water at 60 degrees Celsius, then 180 grams of water is going to dissolve in 180 grams of the salt KNO3 is going to dissolve in 200 grams of water at the same temperature.
Please, I don't understand.
That's why you didn't get it again.
Not me, I got it already.
I'm just joining the class.
Oh, for the person just joining, don't worry, you get it. We still have more examples to talk about, okay? Just be at first. You are going to get it. Yeah.
All right.
Now, let's move to the next one. We have this here. We have which substance is the least soluble at 20 degrees Celsius? Which substance is least soluble at 20 degrees Celsius? So that means at 20 degrees Celsius, which of the substances is going to give us least mass that will be dissolved in 100 grams of water according to the graph? So when you move to the graph and you check appropriately, what will you see? Look at all the graphs the way they are. At 20 degrees Celsius, which one has the least mass? We have KClO3. Because KClO3, it's because KClO3 is going to give a mass of about 0.7, 7 grams.
Yeah.
So 7 grams of KClO3 is going to dissolve in 100 grams of water at 20 degrees Celsius. Do you get that? So that is the list of all of them. If you check all of them, you get to realize that they are more than 7 grams. For example, if you look at the next one, which is KNO3. KNO3 at 20 degrees Celsius is going to give you something like 21 or 20, something like that, or thereabout. Do you get that? So now, if I want to ask you this question, what do you think is going to be the answer? If I ask that, what do you think is going to be the most soluble? No, the question is least soluble, right? So which of the salts is going to be the most soluble at 20?
At 20, KNO3.
KNO3. Look at the position of KNO3. Look at the position of KNO3. Take 20. So what is going to be the mass of KNO3 at 20 degrees Celsius?
20.
20. But there are some that are more than that. Some are more. Look at the curve very well. Let me ask, what is the mass? What is the mass of NaNO3 at 20 degrees Celsius? What is the mass of NaNO3 at 20 degrees Celsius?
80. No.
80 something, right?
Yes.
One.
Yes, 80 something. So fine. So that's the. If you check all other ones at 20 degrees Celsius, there's none of them that is more than what that is. So the next most soluble after NaNO3, ammonia, that's NH3. That's going to be about 65 or thereabout.
Yes. Like 68.
You see that?
Yes.
So that's it. You got the logic. Yeah, I hope you got the logic now. Right?
Yes. So what of the calculation aspect?
So let's look at this also.
This just concluded exam.
Okay, let's leave this. This is what. Which one? This one? Do you mean this time?
The one we just finished solving. This example we just finished solving.
Okay. Let me take this example for the last time, this one. So the question says that which substance is the least soluble at 20 degrees Celsius? That's from the graph, right? So what we do is you move to the graph and you check which of the salt is going to be the least soluble. For you to know that is, you need to check at 20 degrees Celsius, which you trace the curve up and try to check the intersection between 20 degrees Celsius and the y-axis. So which one of them is going to give the least mass of salt at 20 degrees Celsius? So the most apparent of them all is KClO3, because KClO3 is going to give you 7 grams or thereabout. So okay, according to what I have on the slide is 8 grams of KClO3. That's what is there. So 8 grams of KClO3 gives me the least amount of mass of salt that can get dissolved at 20 degrees Celsius from the graph. So, but if you move a bit further, you get to realize that the next curve there is what? Is KNO3. So KNO3 is not as soluble as, is more soluble than KClO3. KNO3 is more soluble because KNO3 is about 20 grams of it dissolving in 100 grams of water at 20 degrees Celsius. Do you get that?
Yes, sir.
So fine. So I was now asking a question here, that what is going to be the source of the highest concentration? I mean, what I mean is the salt that is going to be the most soluble. So that means for you to get the salt that will be the most soluble salt, it has to be the one that's going to have the highest mass present in 100 grams of water. So then what we did was we tried to check the intersection between 20 degrees Celsius and the highest. So we got to realize that the curve with that highest point of salt precipitate is going to be NaNO3, because NaNO3 gives us about 80 grams in 100 grams of water. Is it understood? So that's what I was trying to explain there. So, now, we are moved. This is going to be the last slide, and then with that, I'm going to give you 1 or 2 things to do to evaluate if you actually understand the process. So let's look at this. Can you see this?
Yeah.
Can you see that? So a saturated solution of KNO3 is formed.
Hello.
Hello, I can hear you.
Yeah, you showed
I can hear you, I'm all
slides,
ears.
but it's only one you explain. Okay, you showed 2 slides, but it's only one you explain.
Yes.
The first one.
Yes, okay. The reason why I did not explain this, I said that we are not actually working on gases. So we are talking about solubility of solids. So there's no point in me explaining because it's not in our syllabus. So I don't need to bother us with explanation or something that's not in the syllabus. So that's why I only focused on solid. Okay.
Why don't we talk on it randomly? Like, let us just have an idea.
Somebody saying something?
Yes, I said we should talk on it. Like, I think we should talk on it randomly so that
just
we
have
an
idea.
Okay, no problem. Let me quickly finish this. Okay.
Okay, sir.
Let me finish this. So if you have enough time, then I will briefly talk about it.
Okay.
Because of the time at our disposal. So now here we have how to use a solubility curve again. This is the 5th technicality or the 5th kind of question that can come in, or style of questions that we can meet in exam. We meet this kind of exam mostly, this kind of question mostly in NECO questions. Most importantly in UTME, JAM asks questions on this aspect a lot. So why seldomly is not very rampant in one. But if you know it now, it's going to be an added advantage. And note that these kind of questions are not very frequent in examination. So And WAEC has adopted a style now of bringing up questions that are not frequent. So that's why it's important that you also have the knowledge of this. So in case that this kind of question comes out in your own set, you should be able to know how to answer the questions. So it's very important that you pay attention. Even in most schools, teachers don't really give a lot of attention to this aspect because they feel that
Okay.
out, especially and once we get it now, we get it and that's it. It's very easy. So now a saturated solution of KNO3 is formed from 100 grams of water. If the saturated solution is cooled from 60 degrees Celsius to 20 degrees Celsius, how many grams of precipitate are formed? So that's the question. The question tells us that we have a saturated solution and that saturated solution is cooled from 60 degrees Celsius to 20 degrees Celsius. So what is the mass of precipitate? Because many a time, not all salt, but a number of salts undergoes precipitation when they get cool. So in cooling process, they will precipitate. That is from hotness to coldness. So they are going to precipitate and form certain crystals. So we can use the graph to actually analyze what is going to be the mass of precipitate that's going to be formed during this precipitation process. So we move to the curve. Don't forget it is 60 degrees Celsius to 20 degrees Celsius. Of what? Of KNO3. So let's go to the graph. Don't forget you are talking about KNO3. At the curve of KNO3 from 60 to 60, let's take 60 up, then you link it. Now, can you see my slide, please?
Yes, sir.
Okay, fine.
Yes, sir.
So, yeah, I think it was a network. Let me go back to. So I was explaining this, right?
Yes.
Yeah.
So now let me quickly take it again. So the saturated solution is from 60 degrees Celsius to 20 degrees Celsius. So we want to know the amount or the mass of precipitate formed. So we said you come to the graph here, you locate 60 degrees Celsius, you move up to KNO3 because that's the salt in question. Then you link it to the y-axis. So that's going to give you 90 grams. So that means the mass of KNO3 at 60 degrees Celsius is 90 grams. Don't forget it's getting cool from 60 to 20. So you now move to 20. So you link 20 up to the point where it gets to KNO3 and then you move it to the y-axis. So that gives you what? 20 grams. So that means from at 60 degrees Celsius, you have 90 grams of KNO3. At 20 degrees Celsius, you have 20 grams of KNO3. So what is now going to be the mass of precipitate formed during the cooling process? So what you just do, you do a subtraction of the mass. So it's going to be 90 grams minus 20 grams, which is going to give you what?
70 grams.
70 grams.
70 grams. So that's exactly what is done here. So you can see 90 grams of KNO3 at 60 degrees Celsius minus 20 grams of KNO3 at 20 degrees Celsius. And that gives you 70 grams KNO3 loss. So that's the precipitate. Now, lastly, we have how, okay, 90 grams of KNO3 are added to 100 grams of water. Is the solution saturated, unsaturated, or supersaturated at 40 degrees Celsius? Well, let me ask this question first to see if you actually follow the discussion. So, when do you say that a solution is saturated, and when do you say a solution
One
is
is on the line.
okay? Fine, very correct. So that means you are following. So when the plot is exactly on the line, right? So it means that the solution is saturated. But when it is above the line or above the curve, it is said to be what?
Super saturated.
You said?
Super saturated.
Super saturated, very correct. And when it is below, it is
Undersaturated. Unsaturated.
very correct. So I want you to give me the answer to this, even though the answer is already displayed on the screen. So look at, the question is 90 grams of K at 40 degrees Celsius. So let's locate 40 degrees Celsius. Can you see that? What are we actually talking about? KNO3, right? So look at the curve of
Yes.
KNO3. Can you see the curve of KNO3?
Yes.
Right. So you have 40 degrees Celsius, move it up until it gets to what? 90 of the y-axis. You can see the position of the plot. Here you have that red spot. So is it above KNO3, below KNO3, or on KNO3?
Above.
So it is above KNO3. So since it is above KNO3, it's said to be what?
Super saturated.
Oh, you're all cool. That's beautiful. So it is super saturated. So now, as somebody was saying, we should move back to the saturated, the gaseous part. So let me quickly take gases here. So that I can give you, because I have questions for you to see if you actually understand. So look at this, how to use solubility curve here. It says which compound is likely to be a gas and why. Now, if you look at all gases, all curves, you get to realize that there is only one that is decreasing with increase in temperature, isn't it?
Yes.
I don't know, maybe you are getting it. Look at that red line going down.
Yes.
So it is the only one decreasing with temperature. All other are increasing with temperature. So it is telling us that factors that affect solubility, right, of solid is different from factors that will affect solubility of gas. So one of the factors that affect solubility is that increase in temperature will increase solubility of substance in liquid. Do you get that? Especially when I'm talking about solid. But when you dissolve, when the solubility of gas in liquid, right, as regards to increase in temperature, is not going to be direct, it's going to be inverse. So that means the more the temperature, right, the lesser the solubility for gas. But for solid in water, the more the temperature, the more the solubility. You get that?
Yes, sir.
Do you understand that?
Yes, sir.
No. Yes.
So that's why it is said that the answer to that is NH3, because the solubility is decreasing as the temperature increases. And that's the only one there. All right, so now let me quickly share one other thing with you so that I will evaluate if you actually understand. Okay, so let me go back to my, give me a few seconds, please. Um, Fine. Can you see this?
Yes.
Okay, fine. You guys are going to supply me the answers to this question, but I don't want it to be in the chorus form. So, but I want everyone to get involved. Okay. So, you have this. Now, you are relating the questions with the graph. Okay. So, what mass of solids, right, will dissolve in 100 ml of water at the following temperatures? So, what is going to be the gram of KNO3 at 70 degrees Celsius? Check. Please, you have to be patient and look at it very well. At 70 degrees Celsius, what is going to be the mass of KNO3? That's the mass of the solid.
130 grams.
Any other contrary answer? I can only hear the voice of one person.
Should we start answering from
130.
what masses?
130 grams. Fine.
No.
So it's 130 grams, right? So what you just do is you check 70, you move up until it gets to the curve of KNO3, and then you link it to what? To the y-axis, and that's 130 grams. So that's very correct. Now, B part, NaCl at 100 degrees Celsius. What is that going to be? Yes.
70 grams.
40 grams.
40 grams, very correct. 40 grams. You can see the way that curve is. That curve is almost linear. It is almost straight. Okay. It's
How is it
the
40?
slope of. Okay, somebody is asking now is it 40. Look at 100 degrees Celsius. Move up until you get to NaCl. The curve of NaCl is not actually curve. It is almost a straight line. It is starting a bit below 40. And it is going straight until it's not very straight. It's not at one. It's not what do you call it?
It's not what do you call it?
It is a straight line actually, but the slope is not very much. So the slope is very little. So that's why it is linking at 40 degrees Celsius. 40 grams. So I hope that should be clear. So then C part, ammonium chloride at 90 degrees Celsius. So what's going to be the answer of that?
70 grams.
70, very correct, 70 grams. So which of the above three substances is the most soluble in water at 15 degrees Celsius? Most soluble at 15. Most soluble at 15.
NaCl.
No, it can't be NaCl. Look at it very well. You said? I didn't get what you said.
Potassium iodide.
Yes, potassium iodide is correct. Look at potassium iodide. It's on top there. If you are not very careful, you won't see it. So, at 15 degrees Celsius, potassium iodide, what is going to be the answer? What is going to be the value? It's about 142 or 143 or something. Do you get that?
Yes.
So that's the most soluble at 15 degrees Celsius. So I hope you're following.
Yes, sir.
Yes, sir.
Now, let's look at this. You are going to be using this also. Now, types of solution. This is just to evaluate the types of solution. I want you to tell me the answers straight down. Okay, can you see? So on a solubility curve, the lines indicate the concentration of, on the solubility curve, the lines indicate the concentration of a dash solution.
Saturated solution.
Very correct, the saturated solution. So the maximum amount of solid that will dissolve at that specific temperature. So values on the graph dash, a curve represents unsaturated solution. Values on the graph dash represent, what's going to be the answer of that dash?
On the graph, below a curve represents.
Below, or under. Below or under. Very correct. So values on the graph below or under a curve represent unsaturated solution. I hope others are following. Are we following?
Yes.
Okay, fine. Now here we have labeled the saturated solution or unsaturated solution. I'm going to end the class now. I just want to give you in so that you can do it. I'll give you this as a practice for yourself.
Please,
And then
can you send it to the group so that
no
we'll
problem.
have
I will
it?
do that. I will do that. No problem. So let me just explain this quickly so that you can have time to do more questions on your own. So this one is telling us is telling us that you should choose which one of them is saturated, unsaturated, or supersaturated. And how are you going to know that? Look at, for example, a solution that contains 70 grams of NaNO3 at 30 degrees Celsius in water. So is it going to be saturated or unsaturated? So what you do is 70 grams of NaNO3 at 30 degrees Celsius. You go back to the graph. Don't forget the parameters. You have 30 degrees Celsius, 70 grams, and NaNO3. So let me go back to the graph. We have NaNO3. You can see NaNO3, right? What is the temperature? What is the temperature? What is the temperature? You forgotten? Let me go back so you can see. The temperature is 30 and the mass is what? 70.
Yes.
Oh yeah.
70.
30. Link 30 to 70. Can you see 30 to 70? Where is it falling? Is it falling below, above, or on NaNO3?
Below.
Below. So is it going to be saturated, unsaturated, or supersaturated?
Unsaturated.
Unsaturated. Very correct. So that's how you are going to do all other ones. The way they are in the table. So I think that is clear. So
They said something like if
well, you should be able.
unsaturated, how much solutes can?
Okay. Now, if you want to
Can...
do that, okay, no problem. Let me explain that. I wanted to be silent about that, but since somebody asked the question, they said, if unsaturated, how much more solids can be added? So let's move back. Let's go back to the question for that one that we did. So at 30 degrees Celsius at 30 to what? To 70, right? So we can see that the mass there is 70. Now let's proceed further until it gets to the curve. When you proceed further until it gets to the curve of NaNO3, you're going to get something like 95, right?
Yes.
So then what you do to get the mass that will be added is 95 minus 70. That will give us what? 15.
25. Maybe 50.
Sorry, 25. Do you get that?
Yes.
So what I have done is just, because I want to get the excess amount of, what amount of salt will I add to 70 to make it up to what? 95. You get it? So it's going to be what? 25. Because linking 30 to 70, you get to realize that it is below, it is not saturated. Now to make it saturated, what are you going to do? You are going to add 25 grams of NaNO3 more to make the solution to become saturated. So you just trace it up and then you move to the y-axis. Whatever answer you get, then you subtract the below from the above, and that's it. Is it clear?
Okay. Yes.
So that's how you do that. So I hope the class is the concepts are understood.
Question number 2 says something different.
Okay, let me go to question 2. Question 2 says at 90 degrees Celsius, right? You dissolve 10 grams of KCl in water, in 100 grams of water, right? Is this solution saturated or unsaturated? How do you know? It's simple. So let's go back to the graph. Don't forget 90, right? For 10 for KCl. So the temperature is 90, right? For 10.
Yes.
So it is below. Can you see that? So why? The question is why? Is it saturated or unsaturated? That's the first question. He said, is the solution saturated or unsaturated?
Unsaturated.
Why? How do you know? How do you know? That's the question. The next question.
Because any curve, anyone that falls below the curve is called.
Yes. Any plot that falls below the curve is said to be what? Is said to be unsaturated. So there's nothing difficult. Yes, it's not. There's nothing difficult in it. So, and that's how you can try other ones too. Okay. So do you have questions?
No.
Because it's almost time for Salat, so that we can go and pray. So, any question?
No.
No question. Okay. So inshallah, I will send both the class notes and the material. So who is making the recording, please? I want you to. Okay. I think I should have. Can I have? Okay, the coordinator.
I don't understand the curve.
You don't understand the curve. You came late. Those that said they don't understand the curve, that means they came extremely late.
No, I was with you. You explained the other time, but I didn't understand.
Which one of them?
The answer is how to know if a curve is saturated or unsaturated.
Okay. Is okay. Now let me go. Let me share this back. Let me share this back, please. I will share it to the coordinator, and the coordinator is going to give it to you. Send it to your respective group. So, for the sake of the person who said that I don't understand when it's saturated or when it's not saturated, let me quickly have this for you again. It's very simple. Look at this. Can you see what I have here? Can you see what I have here?
Yes, sir.
So any plot of indication that falls below a curve is said to be unsaturated. But if it falls on the curve, it's said to be what? Saturated. If it falls above the curve, it says to be super saturated.
Okay.
Is that one clear?
Sure.
Now, let me now give you a question related to that. Let's see a question related to that. Now, look at this question. The question says that 90 grams of KNO3 are added to 100 grams of water. 90 grams of KNO3 is added to what? 100 grams of water. Or saturate, is it going to be saturated? Is solution going to be saturated, unsaturated, or super saturated at 40 degrees Celsius? You get that? So what we do is we move to 40 degrees Celsius, we link it up to where we have KNO3. Am I communicating? So, but you will not get to the curve until you have 90 grams. Are you getting my point?
Yes, sir.
It is only at the point of 90 grams you stop. So if you look at the curve, let's look at the curve. Look at 40 degrees Celsius. Can you see?
Yes,
so,
sir.
and look at where 90 is. That is 90 grams. So can you see that that red spot is where the intersection is?
Yes, sir.
So
yes.
now you now look at NaNO3, which is KNO3. KNO3. Can you see KNO3? Is it?
Yeah.
Can you see the curve of KNO3? That's the sort in question. Is the plot above, below, or on KNO3?
It's above.
It's above. So is it going to be saturated, unsaturated, or super saturated?
Super saturated.
So that's it. That's how easy it is. So you got that. So
thank you, sir.
yeah. Subhanakallahumma wa bihamdika ashhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Assalamu alaikum.
Thank you very much.
Thank you.